Okay, everybody, my name is Bill Trautman. I am back. This is the Week 9 live chat for the quiz help for Week 9. There is one problem on here that I could not read in the quiz. I don't know what was wrong. I was using the right browser and everything. I just could not read it. So what I'm going to do is, I don't know if you can read it or not, or if it's going to be fixed by the time you take the quiz. But what I'm going to do is just give everybody credit for one extra problem. So let's say you get 8 out of 9, I'm going to give you the 9. If you get 9 out of 9, you're stuck with 9. If you get 5 out of 9, I'm going to give you 6 out of 9, okay? So I am going to give you credit for an extra problem on this this assignment, this quiz. All right, so for the first problem, Patrick, can you hear me fine now? I just want to make sure. Testing 1, 2. Patrick? Okay, good, good. All right, so write the polynomial with the following solutions. So last week we had, I think we had one very similar where we just plug these numbers in. Do you see if you have the number 3, you're going to plug in the opposite sign, x minus 3 in the parentheses. And we have 2i, so we're going to plug the opposite in, x minus 2i, okay? And it says, write the polynomial with the following solutions. And if you remember last week, we foiled this, and then we had our answer. We had the quadratic answer. But this week is a little different, because when we deal with imaginary numbers, if 2i is a solution, then negative 2i automatically is also, even though we didn't write it. But if a positive 2i is a solution, then a negative 2i is also a solution. So I also have to put x plus 2i. So if you have an x minus 2i, you have to have an x plus 2i. If you have an I, you have to have its opposite sign. Both of them have to be there. Even though it said 2i and 3 are solutions, negative 2i is also a solution. Because for i's, you have to have its opposite sign. You have to have both. So we're going to foil this, but you have 3 parentheses. So you can only multiply 2 together. So you always multiply the i's together first. So that's what I'm going to do. I'm just going to go through the FOIL process. I'm going to do x times x, x times this, this times this, and this times this. So let me see what I get when I multiply that. X times x is x squared. X times 2i is positive 2xi. Then negative 2i times x is a negative 2xi. And negative 2i times a positive 2i, negative times a positive is a negative 4i squared. I times I is I squared. So we just multiply those together. Do you see how 2xi and minus 2xi cancel? So I'm left with x squared minus 4i squared. And there's something we had to remember from the last 2 weeks, if I'm not mistaken. We had to remember that I equals the square root of negative 1. And we had to remember that I squared equals negative 1. So these are 2 things we just had to remember. Do you see how this I square, we're going to change it just to negative 1. We're going to change that to negative 1. So what this really is here is it's 4 times negative 1. So I have x squared plus 4. Negative 4 times a negative 1 is a positive 4. So we just multiplied both of these together, and we got x squared plus 4. I bring down my x minus 3. Uh-oh. There we go. I'm back. My computer froze for a second. Uh-oh, it's still frozen. Give me a second. Okay, bring down the x minus 3. And now we're going to FOIL this. We're going to go through the same process. I'm going to go x times x squared, x to the 1 power times x to the 2 power is x to the 3 power. X1 times 4 is 4x. Negative 3 times x squared is a negative 3x squared. And negative 3 times a positive 4 is a negative 12. So this is my answer. This is my polynomial. I just want to put it in order from highest power to lowest power. X to 3 minus 3x squared plus 4x minus 12. And you always put equals 0 as your polynomial. That's my answer. So you had to write it out. Multiply the i's first, and then multiply the next parentheses against it. Any questions on this, Patrick? How's it look? Oh, that's fine. Okay. Next problem. Find all solutions if one solution is x equals negative 3. So the x equals negative 3 is one solution. We want to find all solutions. So the question is, how many solutions are there? If we have a third power, there's a possibility of having 3 solutions. Fourth power, 4 solutions. Fifth power, 5 solutions. Did you see? That's part of the discussion this week. I think the last question in the discussion, I don't know if it's D or E, the last part of the discussion talks about the power of the polynomial and how many solutions there could be. Just because there's x to the 3 doesn't mean there has to be 3 solutions. It means the maximum is 3 solutions. So there could be 3 solutions. So it says find all solutions if one solution is x equals negative 3. To find the rest, what we have to do is divide this into that. So I'm going to divide using long division, and we all know long division because I think we did it last week or the week before. X3 plus 3x squared minus 11x minus 6. And x equals negative 3. This corresponds to x plus 3, right? Remember, when you put it in here, it's going to be the opposite sign. When you put it in the parentheses, the opposite sign. X equals a negative 3 is x equals x plus 3 in the parentheses. To get the 3 to the other side, you subtract 3 to each side, and you'd have x equals negative 3. So I'm dividing this because this one solution is negative 3. I'm dividing this by plus 3. And I'm going to go through the long division steps. So if you remember long division steps, how many times does x go into 2x to the third? 2x to the third. How many times does x go into it? One of the x's cancel, and we're left with 2x squared. So 2x squared times 2x squared times x is 2x3. 2x squared times 3 is 2 times 3 is 6x squared. Then we subtract, and when we subtract, we change the sign of each term inside. The minus changes this plus to a minus. The minus changes that plus to a minus also. 2x3 minus 2x3 cancel. 3x squared minus 6x squared is a negative 3. Maybe I should change my color there. Is a negative 3x squared. Bring down the next term. How many times does x go into negative 3x squared? Negative 3x squared. How many times does x go into it? One of the x's cancel, and I'm just left with negative 3x minus 3x. Minus 3x times x is a negative 3x squared. Minus 3 times 3 is a negative 9x. We're going to subtract these two. And when we subtract them, you change that. What you do is change the sign on the inside. The minus minus changes to a plus, and this minus changes to a plus. Negative 3x squared plus 3x squared cancel. Here I have a negative 11 and a plus 9. Negative 11 and a plus 9. Negative 11 and a plus 9 is a negative 2. Bring down the next number, negative 6. And how many times is x going negative 2x, negative 2x, x? They cancel, just minus 2. Minus 2. Negative 2 times x is negative 2x. And negative 2 times a positive 3 is a negative 6. We're going to subtract it. That changes the sign of everything in there, plus, plus. What happens is that cancels. Negative 6 and a plus 6 cancels. And we're turned into 0. This is our answer. 2x squared minus 3. Now, that's what our answer when we factored it. The question is find all the solutions. We know up here we circled x equals negative 3 is a solution. We need to find more. So somebody remember 2x squared minus 3x minus 2. Because I'm gonna use this page. Don't worry about this. I'm gonna use this page because I ran out of room. 2x squared minus 3x minus 2. 2x squared minus 3x minus 2 equals 0. So we're trying to find the solution. So this is what we got after I divided this by one of the solutions. And now I need to factor this. So I'm going to factor using trial and error. So I'm just going to go through and factor it. If you guys need to factor it, you can use the AC method or you can use trial and error. Multiples of 2x squared are 2x and x. And then I have negative 2 here. So I can use 2 and 1 or 1 and 2. I'm going to use 1 and 2. Do you see how this turns to 1x? And the outside turns to 4x. We need to end up equaling a negative 3x. So this becomes negative and this becomes positive. The bottom number, the sign goes to the left. The top number, the sign goes to the right. So my solutions are 2x plus 1 equals 0 or x minus 2 equals 0. Now, just really quick, if you don't understand how I factor this, you could either use the AC method or trial and error. I factored it using the trial and error. If you're not sure, go back to the factoring chapter that we went through. Factoring 3 terms when the number in front of x squared does not equal 1. So this is what I got for factoring. Now we just solve for x. You get the 1 to the other side by subtracting 1, subtracting 1. And then I'm left with 2x equals negative 1. And then divide each side by 2. Divide by 2, divide by 2. And do you see the 2's cancel and I'm left with x equals negative 1/2. That's one solution. The other solution, take this 2 to the other side by adding 2, do the opposite math, adding 2. X equals 2. So my 3 solutions, I have 3 solutions here. X equals 2, x equals negative 1/2, and the original problem, I'm going to erase this now, the original problem, x equals negative 3. See, that's one answer, x equals negative 3. And then we had 2 more answers on the next page, x equals 2, and x equals negative 1/2. These are the 3 solutions I found. Really is a lot of work if you're not familiar with the factoring of the 3 terms. And the log division, you see, so we had to do we had to take that first answer we had and then do the long division. I erased it already. And then once you do the long division, then you had to factor whatever was left over, and you got your answers. I hope that helps. That's a tough problem. That's going to be a tough problem for quite a few people. Good, good. All right, so identify the asymptotes. First of all, let's figure out what an asymptote is. It's an invisible line. It's an invisible line. It's an invisible line your graph cannot cross. So let me just show you. Let me show you a graph real quick, and then I'm going to erase this. Let's say it looks like this. We have this graph. It comes up here, and then it goes up like that. There. We might have a graph. It goes like this. So the asymptote is an invisible line your graph cannot cross. Let's say here's my invisible line. Do you see? It's just an invisible line that I have here that the red graph cannot cross, even though it gets really close to it, but it cannot cross. You can put an asymptote right here too. This is a horizontal asymptote. If you put it right through there, do you see your graph does not cross it? An asymptote is an invisible line your graph cannot cross. Okay, so how to determine asymptotes? So we're going to do the vertical asymptotes. All you do is make the bottom equal to 0. X squared minus 9. Make it equal to 0 and solve for x. That's all you do. This factors, two-term method, something squared, something squared. We can put a 3 in here and an x in there. X squared is x squared. 3 squared is 9. Once you factor that, you put two big parentheses. Put an x and an x in the first spot, a 3 and a 3 in the second spot, 1 plus, 1 minus. Once again, if you're not up with factoring, go to the chapter that we did factoring from. Now we solve for x. I have two things multiplied together, and the answer is 0. When you have two things multiplied together and the answer is 0, one of them have to equal 0. The x plus 3 has to equal 0, or the x minus 3 has to equal 0. If I solve for x here, get the 3 to the other side, I'm going to subtract 3. Subtract 3. I get x equals negative 3. Should be a negative. There we go. Yeah, get the 3 to the other side, so I'm going to add 3, add 3. X equals a positive 3. These are my asymptotes. X equals is the formula for a vertical line. If I was going to graph this at 3 right here, I would have my asymptote, the invisible line right there. My graph could not cross it. And also at negative 3, I would have an asymptote, an invisible line my graph cannot cross. These are my two asymptotes, x equals 3 and x equals negative 3. X equals is a vertical line. So all you have to do is make the bottom of any fraction that you have to find the asymptotes. To find the vertical asymptotes, make the bottom equal to 0. And solve for x. And once again, there was one problem I could not read. I'm not sure why. I might be able to read it if I go back there now, but for some reason there was one problem I could not read. So even if you guys can read it, I'm giving everybody one credit back. One problem back to everybody. Find all rational zeros. So this is really similar to what we just did on that first problem where we did long division. See, let's go back. I just want to show you what it looks like. This one, we have this polynomial, and we have a solution, negative 3. Then we did long division. We ended up with whatever was left over, and then we divided. We factored that out to find two more solutions. So they want us to do the same thing with this problem, except they don't give us a solution. We don't have a solution. So what you have to do for this is when there's nothing in front of x3, which is good, when there's nothing in front of x3, we take the last term and find all the factors of the last term. 1, 2 divides into 6, 3 divides into 6, and 6 divides into 6. Also take the negative versions of them. These are all possible solutions. So even though these are factors, but these are all possible solutions. It says find all real zeros. A zero is a solution. So, and it's x to the third, so there's possibly 3 solutions here, 3 zeros. Okay, so how do I find 1 0? Once again, previously they gave us 1 0. They didn't give us one here. What I'm going to do is plug in every single number until this equals 0. I'm going to plug every number in for x. Watch how I do this. I'm going to start off by plugging 1 in for x. Put 1 in there to the third power minus 2 times 1 squared minus 5 times 1 plus 6. If this equals 0, then 1 is the solution. 1 to the third is 1. 1 squared is 1 times negative 2. Negative 5 times 1 is negative 5. Using the order of operations, 1, I get minus 7, and 1 and 6 is plus 7. Do you see how if I plug 1 into the equation, I get 0 as an answer? I get 0 as an answer. 1 minus 2 minus 5 plus 6 equals 0. So 1 is a solution. We can say x equals 1 is a solution. Now we can do the long division. You can do long division, or you can plug in all these numbers to find the other solutions. Me personally, I would rather do the long division. You see, anything that equals 0, let me find a number that probably is not a solution. I don't know. Let's try 2. Let's see if 2 is a solution. 2 squared, 2 to the third power, 2 to the third power minus 2 times 2 squared minus 5 times 2 plus 6. 2 to the third power, 2 times 2 times 2 is 8. 2 squared is 4 times a negative 2 is a negative 8. This is negative 10, and this is plus 6. These two turn to 0, and this equals negative 4. So f to the second power equals negative 4. Do you see? 2 is not a solution because it did not equal 0. We got negative 4. You can plug in all of these, or you can do long division. I'm going to do the long division. So I know already 1 is a solution. So I'm going to divide this by 1 is a solution. I'm going to divide it by x minus 1. Remember, you always change the sign. x3 minus 2x squared. What else? Minus 5x plus 6. Okay, so how many times is x going to x3? 1 x cancels, and I'm left with x squared. So we put that right above the x squared, and we multiply. X times x is x3. Negative 1 times x squared is negative x squared. You have parentheses, you subtract it, it changes the sign of everything in there. This changes to a minus, this changes to a plus. Those cancel. Negative 2 plus negative 2x squared plus 1x squared is negative 1x squared. Bring down the minus 5x. How many times does x go into negative x squared? Negative x squared divided by x equals a negative x. 1x gets canceled. So I put minus x up here. X times x is x squared. Negative x, or negative x squared, negative x times x is negative x squared. Negative x times a negative 1 is a positive x. We're going to subtract this, which changes the sign of each item in here. Negative x squared plus x squared cancel. Negative 5x plus 1x is a negative 4x. And then I'm going to bring down the 6. Something didn't work out right. Hang on. Oh, this was a plus, so it changes to a minus. There we go. That was a plus, so it changed. Negative 5x minus 1x is a negative 6x. The negative 5 and a negative 1 is a negative 6x plus 6. How many times does x go into negative 6x? The x's cancel, and the answer is negative 6. Put negative 6 up here. Negative 6 times that. Negative 6 times a negative 1. And when you subtract it, if they're exactly the same, the signs change, and you can cancel it and it turns to 0. So here's my solution, x squared minus x minus 6. I'm going to erase this part. One is solution. I don't want to erase that part. I want to write it down here. There's my solution. I don't have enough room. X squared minus x minus 6. I got to remember. X squared minus x minus 6 equals 0. Did I see? Yeah, I said it right. Okay, so I'm going to factor this. 1 times 6, and 2 times 3. 2 and 3 will give me a negative 1 if it's a negative 2 and a positive 2 and a negative 3. So this factors to a positive 2 and a negative 3 with an x and an x. Solve for x. X plus 2 equals 0. X minus 3 equals 0. Get the 3 to the other side by adding 3, and I get x equals 3. That's one solution. Get the 2 to the other side by subtracting 2, and that's the other solution, x equals negative 2. So my 3 solutions are, the first one we found right up here, x equals 1, x equals negative 2, and x equals 3. So I think this is a tough section. First, you have to plug in as many of these numbers as you can in here to make it equal 0. As soon as you get one that equals 0, then you could divide that into the polynomial and find your whatever's left over, your quotient, factor that, and then find the other solutions. It's a lot. You might have to watch this video more than once. It's definitely a lot. Let's see what else we got. I know we got a couple of problems more. Maybe just not too much. Only 2. Oh, okay. 3 problems more. Evaluate f parentheses negative 3, right? Well, normally you see this, f of x. But this time we have a negative 3 in the parentheses. That just means, all that means is x equals negative 3. And we're going to plug it into the equation. You see, the equation is equals negative x to the 4th plus x to the 3rd plus 2x squared plus 5. So it's just telling me x is negative 3. So I'm going to plug negative 3 in here. And you have to use parentheses because if you don't, you're going to get the signs wrong. So it's really important. It says evaluate. Find out what the answer is if you plug negative 3 into x. That's what that's saying. So using the order of operations, you can't go negative, negative, positive here yet. You have to go negative 3 to the 4th power. Negative 3 times negative 3 times negative 3 times negative 3 is a positive 81. And then there's a negative out in front of it. You see, we just did negative 3 to the 4th power. Negative 3 times negative 3 times negative 3 is a negative 27. And an odd number of negatives gives me a negative answer. Here, negative 3 to the 4th is an even number of negatives. It gives me a positive 81 answer. But the negative in front is brought down. Negative 3 squared, negative 3 times negative 3 is 9. 9 times 2 is 18. And then we have the plus 5. Okay, so we just add these up. Negative 81 and negative 27 is a negative 108. Negative 108 and plus 18 is a negative 90. Negative 90 plus the 5 is a negative 85. So I get a negative 85. What evaluate f to the negative 3? F to the negative 3. I get negative 85. It's a lot of work here. I hope I'm not going too fast, Patrick. I feel like I'm just zooming through this. We've already been working on it for 30 minutes, though. I just feel like I'm zooming through it. I am so glad that there's a rewind function on this. Uh, yeah, I'm gonna say it's just tough because they want you to find the solution. So that's not easy. The way they want you to find the solutions. Okay, so I kind of remember doing this. No, I don't think we ever have. Describe the behavior at the x-intercepts. Let me draw you a picture of what this graph looks like. I'm going to just show you what this graph looks like. And how do I know what the graph looks like? Well, first of all, I look at this x minus 3. I know the opposite is x equals 3. Do you see? I know that's a solution. I know that's a solution. And x plus 7 means we go all the way to minus 7. And that's a solution also. A solution is a dot on the x-axis where the graph crosses the x-axis or touches the x-axis. Okay, do you see how the x to the third, x minus 3 does not have a power, but the x plus 7 has a power of 2. It's important that we look at this. Let me, because I kind of like erased it all. It's important that we see the x plus 7 has a power of 2, and the x minus 3 basically has just a power of 1. There's an invisible 1 there. It's really important to see this. Even powers. If you have even powers, the graph bounces. If you have an even power, the graph bounces. Now, the quiz might use other wording, but the graph bounces. Odd powers, the graph goes through. Do you see at x minus 3, there's no power for it, so it's a power of 1. It's odd. I know the graph is going to go through it. Do you see an odd power? That's supposed to say through. The graph goes through that x3. Now, when we get to an even power like the square, the graph is going to get right up to it, but it's going to bounce off of it. It's going to bounce off. That's important. It says, describe the behavior of the x-intercepts. Well, at x equals 3, that minus 3, that's x equals 3, the opposite sign, it's going to go through. There's an R in there somewhere. At x equals negative 7, because of the even power, it's going to bounce. So there might be other words, but it's bouncing for an even power, going through for an odd power. If I had x to the third power, it would go through because that's an odd power. It would go through the x-axis. I hope that makes sense. So and just to show you, I'm going to just do something again. Let's say it's this, x minus 3 to the fourth power and x plus 2 to the third power. What would I say? At x equals 3, the graph is going to bounce off of it because we have an even power. Yeah. And if we have this at x equals negative 2, odd, you go through. Exactly. Now, they might not use the word bounce. I'm trying to think of what else the quiz could use instead of bouncing, ricochet. I don't know what it just know it bounces, and whatever word they use, they'll go. And odd powers, it will go through. And the last thing I want to talk about is 4 different graphs. So I want to give ourselves 4 different graphs. So let me show you 4 graphs. It's important to know the basic shapes of these graphs. So let me give us 4 graphs and just know the basic equation and the basic shapes. Okay, so one of the graphs I'm going to draw looks like this. One of the graphs look like this. One of the graphs look like this. And one of the graphs look like this. So these are 4 basic shapes. This one, a graph that looks like a U, is a basic x square graph. If you have a graph with the highest power x square, and you could have anything else, x squared plus 2x minus 7, it's going to look like this. It's going to look like a U-shaped graph. If x squared is the highest power, it's going to look like a U-shaped graph, okay? Now, if the U is upside down, then it's a negative x squared graph. It's an x squared with a negative in front of it. If the U is upside down, it's a negative x squared graph. Now, I'm not just talking x squared, but that's basically what it is. It's any even power. This U shape could be an x4 graph. It could be an x6 graph. So U shapes are pretty much even powers. This graph down here is an x3 graph, an odd power. The right side, do you see how the right side is higher than the left side? That's a basic x to the third graph. The right side is higher than the left side. This one is a negative x3 graph, where the right side is lower than the left side. So it's important to have these in your head. And by the way, if you have an x5, these are odd powers, or a negative x5. It's the same thing, odd power graphs, but you can't use this for x to the 1. So odd power graphs, positive in front of the x3 like we have here. The right side is higher. Negative in front of the x3. The left side is higher. So just know these 4 great basic graphs, because it's going to ask, hey, which one is this right here? Yeah, it says, hey, which one is that one right there? And if you look, a negative in front of the x3, a negative in front of the x3, out of all these graphs, the left side is going to be higher because that's a negative odd-powered graph. Exactly. All right, and that is it. That's all I had for the quiz help video. Once again, I'm going to give everybody one question back, whether you can see it or not. Yeah, I know a lot of people do. We just the school.